So welcome back, guys. Today I would like to more or less demonstrate to you how we could implement like statistical supervised learning in Rust using just the Polars library and of course some simple mathematics. So we're going to focus mostly on linear regression as a simple example, and then we'll try to of course cover the entire process from data preparation to model evaluation. So for in terms of structure, I'm gonna maybe create a file again, like here, like we used to do, readme.md. And in here, what we're gonna do is also really gonna be straightforward. So I can maybe say table of content. And what I would like to do here would basically I'm going to keep it quite simple. So we generate some data. So this is like more or less the process we're going to follow. So generate some data and then we will import linear regression. Again, like I said, I'm just going to keep it quite simple and basic. So we're not going to really focus on like using like tons of crates. We're just going to use pandas to handle our data, but I'll try to make us more or less do simple mathematics basically. And then the next thing, of course, we can do would be maybe to do some simple evaluation. So I'll call this evaluate matrix. And the matrix are just going to be things like mean squared error mean squared error, and of course, the R squared error. So I'm just going to call this R squared. And again, to make it a little bit interesting, we're also going to do some visualization, and yeah, we'll do some cross validation. Come on, Tony. We'll do some cross validation, and of course, maybe this, of course, would use this to kind of like improve our performance assessment more or less. We do something like feature, come on, feature scaling, and then I don't know if we would have time, but I can also show you how we can handle categorical data. We might try to implement one-shot encoding. I don't know how much time we'd have. So these are some of the things I would like to for us to cover in this series. I will try to again keep it as basic as possible. Again, the point for me in this tutorial will more or less to show you what's possible with Rust, of course, and the aspects of doing data analysis and even going further to like machine learning and of course the rest. There are a lot of works, of course, happening along currently to more or less improve this area while working with Rust. Of course, the point is not that this dethrones Python at the moment, in my opinion, but just that Python can actually leverage a lot from Rust. So in the previous series, I showed you how we can actually write like some or more or less improve our code by writing it in Rust and then having this compiled to Python using the PyO3 crate. So again, this could be some aspects where you feel like there needs to be some improved performance in some aspects of your Python code. You have the option, of course, to leverage or what's already within the Rust ecosystem to implement this in Rust, and then have this, of course, compiled to Python, and then there you go. You have this again using this in your Python project. So there's a lot more to leverage from here. So that's why I said I don't think the point for this is to replace Python, but more or less to actually enhance and bring up a lot of the benefits that I already have from Rust over to Python. Some things I would like to, of course, to know in this in at least after this tutorial, I'll just call this good to know, is that I would of course need you to know the Polars crate. So you can get this as polar.rs. I'll also need to know about these packet file tabs. So it's actually an open source column oriented data file format, developed by Apache to like for efficient data storage and retrieval. So this really helps a lot when working with data in columns. More or less, this can then, of course, if you think of it in terms of data frames, this will now translate to like a column more or less. Um, when you're working with pandas like you code in Rust. But the point, of course, is that with polars, you can exactly do everything you could, more or less everything you could do with pandas, and even more. So I will try to, of course, show you more how much is possible in this tutorial, and the end, of course, also give you something to, read on your own, and maybe, of course, expand your knowledge much further. So again, these are the two things I would really, really expect you more or less to have as key takeaways from this tutorial. Maybe what I can actually do is to do another tutorial where I simply show you how you can work with these packet files with Rust, of course. So maybe we'll read writes and we'll write to a file, the packet file, we'll read the file again, we'll read the data out of the file, we'll process this, we'll, I don't know, do whatever it is we want to do, just to also show you how this could be done in essence. But of course, let's focus on the idea of this tutorial. So we'll try to see if we can cover most of these points with Rust. Again, like I said, would use just the polars crate and a little bit of some mathematics. That's basically what we'll be doing this series. So let's proceed, guys. If you look over here, I've created a new project as usual. I just named it data science. It's completely empty. So I'm just gonna come here and initialize a new project. So I can simply say cargo init, and then this should create a new project for me. Of course, I have here my main.rs, and now what I can also do is cargo new. I want to add a library, and I can call this I don't know, ml learn, something like this. And oh, that was not what I, okay, I would maybe do something like this. I'd like to put this inside a separate folder, so I can say creates, something like this, and I would have this inside this folder, of course. And then I can come over to my cargo toml, and I'll now, of course, hook up those dependencies in here. So, of course, the first thing I would probably do would be to just create a workspace section in my cargo toml, and then I add my members. So my members is just going to be one for now. So it will be at creates and ml learn. As simple as this. And then in here, I'm just going to add this in here so I can use it. So I'm just going to add path. It's going to go be at create/ml learn. Like this, as simple as this. And I think I'm already making a mistake. So ml learn. So I'll replace this and this. And I can actually go in. No, now I can actually delete this because I wanted this to live inside this crates folder. So I go to the cargo toml, and in here, I'm just going to create a lib section. And here I can just provide a name. So name would be learn. And maybe I also add a path. So path is going to be at source on lib.rs. So I should have a librs in here, and I have a add function. So what that means now is, of course, I can come to the root of our project, come into main, and then in here, just to be sure that everything is properly set up, I should be able to use something like maybe stand create learn. Okay, go away. And now in here, I can now also print line, and I'll say something like result of the add function. I don't know, something like this. And I actually provide that. So I say and learn, and I call the add method at 4, and I don't know, 7, whatever. And so now I should come and go away. So now I should be able to say cargo run, and this should of course compile both our crates, the one we have in here, and then um, of course, because we are now adding this of course in our cargo toml as our dependency, we'll of course pull that from in there, and now we're able to do something like this. So that's really how I want to do it. So in the end, most of the implementations we'll do will of course be inside this ml learn crate, and then the point of course is just to make it reusable and completely independent of our current project. So we can pull it out from here and put it anywhere else. And if it's something that makes sense in the end, maybe even publish it, and then we can use it however we want to do it. But of course, I want to make that completely independent of our root project. But anyways, so with that setup, what I would like to do now is, of course, to add the dependencies that I need to work in here. So I need nd array. So this is going to help us. Is basically like what it sounds like. It's going to help us to work with n-dimensional array. So I'm going to get 0.16.0. Aside from that, I'm going to, of course, get rand. This I'm probably going to use this to generate random data. And in the end, I might also even pull this from some CSV file. We're just going to see how. Let's just proceed anyways. So I need the plotters package. Again, it sounds like it's what the name connotes. So we're going to use this for plotting and visualizing our data more or less. And then, of course, I need CSV. CSV is going to be version 1.3. It's going to be 1.3. And the last but not the least, I'm going to bring in, of course, polars. So I'm going to, of course, specify my version. So version is going to be 0.44. And feature, I'm just going to add the lazy features. So I would simply say lazy. And I think that's all the packages would actually be needing. And we're now just going to proceed and start setting up our project. So I'm just going to create a bunch of files here in the root of our ml-learn create. That's going to hold most of whatever we'll be doing today. So I will need one that says statistics.rs. I'm going to create a new one that says maybe one for data processing.rs. I'm going to do some evaluation. So I can have one that says evaluation.rs. And I'm going to have one, of course, because you mentioned it, that says linear regression. .rs. And let's see, I could also have one that says neural network.rs. And now what I can simply do is, of course, to come in here and bring in these files that we just created. So I can just come in here, expand this, and I can say mod data processing, mod evaluation, linear regression, neural network, and I think statistics should be the last one. So now we have all of this. The next thing, of course, for us would be to just go in those files and start setting things up. I think we're going to actually overlook this for now. I'm probably even just going to comment this out because I don't like these errors popping up every now and then. So for probably going to start with statistics. I'm just going to keep it quite simple. So in here, I will need a couple of functions. So I will need a mean function, and that's going to return an F64. It's going to be a float. And this is probably the signature of most of my functions, the ones I'm going to write here. So, but it's of course going to take a data that's going to be of type array view one, which should, if everything works well, should actually be coming from nd array. Why am I not getting IntelliSense array view one? And is that even what is going on? Let me see. So now my IntelliSense is back and we can actually proceed. So now I need to provide a type. Again, this would of course take an array of floats. So I'm going to make maybe this F64. And what I can do is probably copy this, and of course don't worry about these errors because we promise a return type and we don't have none. We have none yet. So I would duplicate this a number of times based on the statistics I would like to actually perform. So I would like to have mean, and now after mean I would like to have variance, and after variance I'm gonna have standard deviation. You would have already guessed. And now maybe now I have covariance. These are like basic statistics, I guess. So, and then of course, I'm just gonna have correlation and maybe probably stop here for now. Actually, I don't want to make it so complex, but just to show you what's possible. Okay, so now I'm gonna take this away and maybe even collapse it because we don't really need it. So for our mean, it's really going to be quite straightforward. So simply do data dot mean. Should have a mean function and simply unwrap the sets. So this should of course give us a float. Why do I, okay, now everything looks good. So for variance, again, it's going to be quite straightforward. So I can now get a value here and I can simply call mean on my data and I pass my data. It should give me um, my mean. But what I can also do is instead of doing unwrap, I can say unwrap or else. And I provide, just in case this fails, I provide a value here and maybe I just provide 1.0. I don't know, something like this. So just to be sure that I always get something back actually. So here I have my mean, and now what I can simply do is I iterate over my data. So I call the iter method, and then on my iterator, I provide a map. So in here, what I'm just gonna do is pretty straightforward. So I'm gonna take a reference of each of the values I'm passing in here. I'm just gonna call it X. And then in here, what I'm gonna do is to, of course, subtract this from my mean. So minus mean, subtract this from my mean, and of course square this. So I can call power this one and provide a value. In this case, it's going to be 2 because, like I said, we have to square this. And now I want to get the sum. Let me see. Of course, after this point, I can do a sum. So I sum everything, and of course, maybe let's see, and then maybe of course divide this by the length of the data, I guess. So now I can say data dot length to get the length of the data and remove 1, of course subtract 1, and then I'm going to pass this as a float, and I think that should do it. Let me see. Yes, of course, maybe here I would probably need to hint the type here, or more or less. So I can do something like this and say F64. So this should do it, I guess. Yes, so now we have our variance. And for standard deviation, it's also going to be pretty straightforward. So standard deviation is simply the square root of the variance. So for that, again, as you can already imagine, we can reuse our function. We can simply call variance on our data, and we simply do a square root. And we have our standard deviation. It's actually pretty straightforward. And maybe I implement the correlation first, and then we, of course, now come to the covariance because this might take a little while. So, but for the correlation, I'm going to, of course, be passing to arrays. So the first I call come on x. So the second, of course, would be, I'm just going to call it y, and then, of course, this should still be x64. So we take two arrays, and what we need to do, the correlation, of course, between these would simply just be the covariance of these two data arrays divided by the standard deviation of both, the product of the standard deviation of those two arrays. That's how we find the correlation. So we can simply call the covariance method, which we have up there, which we have not implemented, of course. Maybe it makes more sense actually to implement this first. Okay, let me do that actually. So for covariance, again, I'm going to need something like this because I would need two arrays to calculate the covariance. So with this in mind, of course, one important thing is that these arrays, they both need to have the same length. Otherwise, we're going to have a problem. So I'm just going to do a simple assert. So I do a simple assert equal. Of course, this I'm just taking a shortcut. But yeah, so I do a assert to actually check the length of both arrays. So if not, we're going to get a panic. We're going to get some error. So now what I want to do is going to be again simple. So I need to get the length of our x axis, and I'm just going to call this L n for now, and then I can simply say like x dot length, sorry, dot length, as I'm going to type this, so it's going to be f64. Go away, no, go away. So I have the length, and now what I need to do is, of course, to calculate the mean of both those two arrays. So I can say mean x would be equal to, I simply call our mean function, and then I say mean y would be calling the mean function again on y, and of course they both will give us f64's floats. So now I can simply iterate over my x, and then of course I need to pay attention to both. So now I zip it, of course, with my y. I simply call the eta on y as well to have this, because now I need to, of course, perform my operation on both arrays, but of course I want to have them side by side basically. So I can do a map. And the map again, we're just going to take each individual items from both x and y. So I'm probably going to call this xi, not x1, and yi. So I'm going to take a copy of them both, maybe actually a reference of a copy of both of them, like this. And now I simply, of course, multiply the product of the subtraction of each from their means. So I would do something like this. So xi, I subtract its, let me give some space here, I subtract it from mean x, and multiply this by doing same again. So y, if I can type, subtract this from y mean, or is mean y, and what I can now simply do, of course, we just after this whole thing, to sum everything up. So I can simply call the sum method on this, and of course divide this by the length of our data. So I can simply say sum. Again, I'm going to do something like we did before. So I'll provide the type. So it's going to be f64, and I do a sum common, and then I divide this by the length of our data, which in this case it doesn't really matter because x and y have the same length. So in case you're wondering why we chose the length of x, it doesn't really matter here. Of course, this is not closed. Okay, let's see. So now we have our covariance, and what we can simply now do, of course, would be to use this down here. So I'm just going to pass these two arrays we have here, so x and y. And then we simply now divide the covariance, like I said, with the product of the standard deviations of both arrays. So I'm going to put this in quotes and call this standard deviation function. We have provide x, and multiply this by standard deviation of y, something like this. So this should be pretty straightforward. And actually, that's all the basic statistical measurements would be taken for now. Of course, you feel free to add more. I just feel like those might not be really relevant things like mean, median, mode, and stuff like that. Doesn't really matter so much for us right now. So let's focus on these ones, and of course, see how far we get. So the next thing I would like us to do would be data processing. This is also going to be quite straightforward. So what I would like us to do here it would be to, I'm going to keep it simple, three basic things. So we should be able to load data from a given CSV file. We should be able to normalize the data we have, and we should be able to split our data into training data sets, and of course testing data sets, which is like the really basics. That's what we'll be doing here. So I need a function called load CSV. I want to specify the file type, and I need to again provide path to the file. It should be of type str string. And if everything goes well, we should be able to return a result. So in the result, we'd have two things. One would be our data set. The other one, of course, would be a dynamic error. So I'm going to put this in a box, say dyne error. So this is going to be like standard error, nothing so fancy for now. And of course, our data sets should be coming from our it should be coming from like something we will have to define for ourselves. So to clear this up, I'm just gonna maybe bring in our standard error. So std and error. So take this one out. And of course, now I would like to define a struct that's going to define our data set. So prop struct data set. And then in here, I'm going to add just two attributes. I'll call one features. So when we extract features from our data, I would like to, of course, store this in here. So arrays 2, 1, 2. And then it's again, provide the type is going to be F64. And the next thing I want here, I need to add a comma here. So the next thing I want, of course, will be my target. Again, it's going to be, I'm going to probably just make it array1 for now. So array1, where are you? And again, I make it F64. So this is going to be our data type, our data set, sorry. And then, of course, we have our error. Now we need to provide, of course, the body of this file. It's going to be, again, pretty straightforward, nothing fancy in here. I'll try to keep it as simple as possible. So I'm going to instantiate a reader. So come on. So I can say let's mutable. I'll create this, call this reader. So this is going to come from reader, of course, from CSV reader. And then I need to go to from path, this one. And I pass the file path like this. Again, I can now, of course, use the question mark syntax because, of course, that should be able to handle this for us and return the error if there happens to be one. If the file, for example, doesn't exist and no file exists at that location. So I would like to, I don't know, maybe extract the header. So I can call the very handy function called headers. So I can say reader that's headers. And of course, this takes ownership. I'm probably just going to clone it. So I can call the clone method to get the headers. And now I can, of course, instantiate my features. So I can say features. If I can type. So features, come on. I'm just going to instantiate a new vector. I hate this JavaScript rubbish. It keeps pissing me off. And again, targets, vector, and it's called the new method again. Of course, it's unknown for now, but of course, when we start populating this, we would know it's going to be F64. So now I just want to look at the records, the record we have. So I can simply say for result, this is me looping through our records. I can say it's called the reader and call the records common records function. And I loop through this, and now I would like to, of course, extract the data and populate them where they need to be. So I can, oh, come on, I can now look through the records that I get. So in this case, this record, of course, would be coming from, of course, the content of our CSV. So I can say, let's record. I'm just going to put this in a new argument. This is just going to be coming from our result. And this should be optional, a result, of course. So I'm just going to, again, use the question mark syntax to take care of that. And now I like to create a mutable row because now I like to, of course, populate this with the data that we get from that record. So I can say vector.new, yes, new. And now what I will need to do again would be to iterate through our record and of course then populate. So again, I use my for loop to do that. So I have my for loop is just going to be quite handy. So value, these are the two things I'm expecting. So it is going to be from our record dot iterator. So we want to iterate through our records and of course enumerate um, through them. And once we have that, we can now actually just start populating them both on our targets and of course on our row. But of course, before we do that, I have to do some checks. So I can do a simple check and say if I of course is equal to record.length, if it's equal to the length of the record, of course -1 because of the indexing. If this is the case, now I need to populate this to our target. So I can simply say target.push. And in here, I pass my value and of course I parse it. And parsing it, of course, is not enough. So I like to, of course, provide the type. Again, I do something like this. It should be F64 float. So if this is the case, I would like to populate it this way. Otherwise, what I know what I have is, of course, should go into my rows. So I can say row.push. Again, I do something quite similar. So of course here we get a result and I need to handle that as well. So now I can just copy this one, what I have here, and again, just dump it in here. Okay, so now in the end, at the bottom here, I would of course now like to populate my features. So I can say features.push, and now I simply pass my row. And that's basically what this would do for us. And now the last thing, of course, we can do would then be to define what we want to return. So again, I would now maybe create a new argument here called features, and this would just be me trying to more or less return this as an array. So I can simply say array2. I'm just going to use array2, and I say from shape fetch from nope, I don't need this shape function. Come on, I need shape fetch, this one, okay. And then of course I provide the shape. Again, this is going to come from my features.length. And of course the next thing of course would be actually this should be two-dimensional, I think. So what I can actually just provide here, I'm just going to copy this, cut this actually, and then in here I'm going to provide two arguments, the length of our features. And of course, I'm going to extract the first value, so I can do something like this features, the first argument, and then of course the length. That way I can properly get the actual dimensions of the vector. That's really the point here. And then for the second part, again, I'm just going to, of course, this will come from my actual data, so I can do features.into iterator, and now I flatten this and collect this into a vector. And what I can simply do, of course, would be to again handle our errors in case there are any. And then, of course, I do the same for my targets basically. So I can say array1, and I can now again now maybe I just say maybe from vec. And in here is going to be pretty straightforward. So I simply just provide the target because again, I know what's the structure, the setup of how my target is going to look like anyways. So, but in here now, I simply return what I need to return. In this case, of course, it should be a data set. So I can simply say data sets. And in here, we'll provide the two important things that we just created, and which are features and targets. And that's all we need actually for implementing our reading of our CSV file, regardless of the shape of our CSV file. And now, of course, we have errors with our target and features because they are not mutable. Again, pretty straightforward. Simply make this mutable and, of course, do the same here as well. And that should now become mutable as well. Okay, so that's what we do to load our CSV file regardless of the type or the shape of the data, more or less. Okay, so now the next function I would like to create would be, I can call this normalize. So it's going to help us to basically take an array and then normalize the data. So it's going to take a data, which again is going to be of type, it's going to be more or less a immutable reference of our array. So I'm going to make this array 2. And again, the type is going to be F64. And so it's really not going to return anything. It's going to take a mutable reference and simply mutate the data itself. So there's really no need to return something here. So I can simply do something quite simple. So I loop through the data columns. So I can simply say for column in data dot columns mute, because I want to mutate the columns themselves. So we loop through the columns. Now I can get the mean value this way. So I can simply say column dot iterator, turning this to an iterator, and then call the fold function. And within the fold function, of course, I need to provide an init and, of course, a function more or less. So here is going to be straightforward. Our init function, I'm probably just going to do F64, and I do maybe infinity like this. And now for the function here, we're simply just going to pass a more or less like a serverless function. If you think about it like you have in other language, of course, like Python. Sorry, not serverless function, my bad. A closure function, basically. That's what we would have to pass in here. So again, I'm just going to pass, just define the function. This way is going to basically take 2 arguments, both of which are going to be, both of which are going to be F64s. I'm just going to call them A and B. And what I simply need it to do would simply just to return the max. So I can simply say A max B, something like this. And this, of course, would return, sorry, this should be mean. And this would return more or less our the mean value. And we again do the exact same thing for our max, but of course paying attention to the direction of the data. So here I can say let's max. I will do the same, but the only thing now here I can change this to max. And here I'm not just going to go to infinity, I'm going to go in the other direction. So I'm going to go to negative infinity like this. And so that's again one way we can, of course, extract this. And in the end, what I need to do, of course, would just be to update our columns basically, and then return this. So I can simply call column.mapv. Where is it? If I can find it in place, and then in here I simply again pass a closure. So it's going to take an X. In this case, of course, it's going to be, of course, an F64. And now what I can simply do is to X minus in mean, and then I divide this by max minus min. So max minus min. So that's normally one trick, of course, to normalize your data basically. So with that implemented, the last thing that I would like to do in here would, of course, be to show you how we can create our test train split. So again, gonna be pretty straightforward. So I'm gonna call it the exact same thing. I'm gonna call it train test command split. It's gonna take our data set. So a reference our data sets. And what else should we, of course, maybe a size. So I can call this maybe test size. So we have to specify, of course, the size. In this case, I'm just also gonna leave it as F64. And when it's done splitting, I would like it to, of course, return 2 items for us, and they should, of course, as you can already guess, be both of type data set. So it takes our actual data and then splits it into 2. That's really the point, giving us the one we can actually use for testing and the one we'll use for validation. Okay, so I need to define here the number of samples. Again, this is going to come from our number of rows. So I can say data sets at features, and now I need to look at the number of rows, and then I have that. Then now I need to, of course, now define my number of tests and number of train. So I can simply call it n test. N test is simply, we'll do a simple mathematics. So because we want to, of course, take a fraction of our total value. So I can say do something like n samples. Of course, this is going to be of type F64, so I simply specify that because I know the other one is of type F64, and I multiply this by my test size, as you can see here, and then of course round that up. So I can call the round method on this, and then I want to return this again as U size because I want it to be compatible, of course, with the one we've defined up there. So now our n train is again going to be straightforward. We simply subtract from our number of samples. So we simply do, of course, n samples, and we simply subtract the number of our test data. So n, come on, n test. And now we have those two numbers. So now, of course, I would like to create, use this to split both our features and our targets, because again, we need to create more or less two data sets from this one data set. So I can say train, for the train data, we need to create its features and of course its targets as well. So I can say data sets, and we look through the features, of course, and we slice. To provide this slice, of course, I need to use the slice macro that comes with ND array. So maybe I bring that in here, or yes, maybe I can simply just bring that in here. So it's just S like this for creating a slice. So that's probably the shortest name for a slice I ever see in working with Rust. But anyways, so for the slice, we're simply just going to use this macro to create the slice from the our data. So this is going to go from 0 to our number of train, and we do it like this. Of course, it should just be like this. And then now I, of course, maybe do this to owned. Yes. And what is the error here? Do we have an error? No, we don't. It's just my IntelliSense misbehaving. So I do the same for the target. So we have the features, and now we have for the target, so train target. And just to keep it simple, I'm just first gonna copy everything in here and paste that in here. So, but of course, the only thing that needs to change, of course, would now be we'll be going to the targets like this. Oh, come on, I hate this JavaScript shit. Sorry, I hate this JavaScript stuff because it really keeps wasting my time. And of course, I can now, what is the error that I'm having here? Of course, yes, sorry, I don't need to do this anymore. And now I can maybe actually copy this and do the same again for our target, and then we return this. So doing same for our test targets, now we simply just return what we need to return. So data sets, data sets, and of course we provide come on, we provide for the features. Features would of course be train features, and then targets would of course be train targets. And we do the same for our test. So data sets, features will be our test features, and targets would be our test targets like this. And that's how we satisfy this function basically. So these are the functions I would like to, I don't know if we would need to implement more going forward, but I think this is all we need for now. So let's really proceed.